Hello everyone. This is our fifth lecture of module 2, that is lecture number 2.5, and today's topic is Maclaurin's MVT or Maclaurin's theorem. Okay, so let's start. Maclaurin's theorem. Okay, so first of all let me write the statement of Maclaurin's theorem, then I will discuss how to remember this theorem. Okay, concept is same. You will have a function f and an interval. The function will be continuous on closed interval and differentiable in open interval. Okay, then you will get the expression. So let's just start. Let f be a function defined on here the interval is minus h comma h. Okay, minus h comma h, that means left hand side and right hand side from the origin at equal distance, minus h comma h, and where h is greater than 0. Clear? Obviously distance that must be greater than 0, such that number 1 will be f n minus 1, that means n minus 1th derivative. So f n minus 1 is continuous on minus h comma h, obviously closed interval. Number 2, f n exists on open interval minus h comma h. Okay, then there exists at least one number theta where 0 less than theta less than 1, such that f of x, this is equals to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 plus dot 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 last term x to the power n minus 1 by n minus 1 factorial f n minus 1 0 plus x to the power n by n factorial fn theta x. Okay, this is the Maclaurin's theorem. Now let me explain the statement. Okay, so first of all let's write the Taylor's MVT, that second form of Taylor's MVT with Lagrange remainder. Okay, let's write second form of Taylor's MVT with Lagrange remainder. So what was the result? Fx is equals to f of a plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a plus dot 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 h to the power n minus 1 by n minus 1 factorial f n minus 1 a plus h to the power n by n factorial fn a plus theta h. This was Taylor's MVT, a second form of Taylor's MVT with Lagrange remainder. Now just put a is equals to 0 and h is equals to x. Just put a is equals to 0 and h is equals to x. So what will happen? Just put a is equals to 0 and h is equals to x. So sorry, this was f of a plus h, na? This was f of a plus h. Okay. Now what you have to put, a is equals to 0 and h is equals to x. So let's start. A is equals to 0, so this will be 0 plus x, that means f of x. This is equals to f of a, that means f of 0, plus x into f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 plus dot 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 x to the power n minus 1 by n minus 1 factorial into f n minus 1 0, and the last term x to the power n by n factorial f n a plus theta h. A to 0, h is x, so this will be theta x. Now compare this result with this result. Same na? That means just you have to remember the Taylor's MVT, second form of Taylor's MVT with Lagrange remainder. Now in this result, put a equals to 0 and h is equals to x. You will get the Maclaurin's MVT. Very simple. Okay, so fx equals to f0 plus x f dash 0 plus x square by 2 factorial f double dash 0, x cube by 3 factorial f triple dash 0, and so on. And the last term is x to the power n by n factorial fn theta x. And obviously this is known as Lagrange remainder. Lagrange remainder. And similarly you will get Maclaurin's theorem for Cauchy remainder, and I am not discussing the Cauchy remainder portion because this is not so important for your semester examination. Okay, so let's start using Maclaurin's MVT. Let me tell you, Maclaurin's MVT is very important. Okay, using this result you can solve many problems. Clear? So let's start. Question. Question is, using mean value theorem, show that sin x is greater than x minus x cube by 6. Okay, here given if 0 less than x less than pi by 2. 0 less than x less than pi by 2. This is the expression. Okay, let me tell you, here given that using mean value theorem, they have not mentioned Lagrange mean value theorem, Cauchy mean value theorem, Taylor's MVT, nothing. Now problem is, you have to understand which MVT you have to apply. Okay, now here in this expression, is there any value of a? Is there any value of a? No. This expression is x, depending on x. And we know the another form of Lagrange MVT and Taylor's MVT depending on x. Yes or no? But in Lagrange MVT, there was the expression that fx is equals to f0 plus a plus x f dash theta x. Okay, but we cannot apply this result because here we need the greater than sign. That means the inequality sign. So let's use the Taylor's MVT. But can we use the Taylor's MVT? Because in Taylor's MVT we have some particular value of a. Okay, a may be non-zero, may be 0. That means we need an MVT where a is equals to 0. Then we will not get any value of a in this expression. So obviously we have to use Maclaurin's MVT. Clear? So let's start. Here the expression is up to 3 terms. Yes or no? Expression is up to 3 terms. That means we have to write the expression up to 3 terms. So the remainder portion will be in for n equals to 3. Clear? So start. Solution. Acha, by Maclaurin's MVT, you know fx is equals to, just I am writing the formula, f0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash, obviously for n equals to 3 na, so this will be f triple dash theta x. Clear? And you must have to write 0 less than theta less than 1. Okay, 0 less than theta less than 1. Now fx equals to sin x, but we don't know the value of f dash 0, f double dash 0, f triple dash 0 and so on. So let's write this is equation number 1 and find out the values of those. So fx equals to sin x. Okay, so what will be f0? Sin 0 equals to 0. F dash equals to f dash x, this is equals to cos x. So what will be f dash 0? Cos 0 means 1. F double dash x, this is equals to minus sin x. So what will be f double dash 0? So this is equals to minus, so this is 0. And the last term f triple dash x, derivative of sin x is cos x, so this will be minus cos x. So what will be f triple dash theta x? So this is equals to minus cos of theta x. Okay, now just put this value, putting in equation number 1. So what you will get? Fx, that means sin x. Sin x is equals to f0, that means 0, plus x f dash 0. So x into 1, that means x, plus x square by 2 factorial into 0, that means 0, plus x cube by 3 factorial into f double dash f triple dash theta x, that means minus cos of theta x. So you are getting sin x equals to x minus x cube by 6, 3 factorial means 6, into cos of theta x. Let's say this is equation number 2. Now problem is we have this inequality sign. Okay, and we know that we can get inequality sign from the expression 0 less than theta less than 1. Clear? Also here given that the value of x is in 0 to pi by 2. Okay, the value of x is in 0 less than x less than pi by 2. Okay, and we know the value of theta is 0 less than theta less than 1. So from this, what you can say, if I multiply theta and x, so obviously this will be 0 less than theta x less than pi by 2. Just multiply each term. Okay, 0 less than theta x less than pi by 2, obviously we can say. That means in this expression cos theta x, this angular value is between 0 and pi by 2. Yes or no? This angular value is between 0 and pi by 2. And in between 0 and pi by 2, what is the value of cos theta? That means what is the value of any cos, any angular value in between 0 and pi by 2. So between 0 and pi by 2, cos will be always between 0 and 1. So obviously we can write that if 0 less than theta x less than pi by 2, then in this expression cos value is 0 less than cos of theta x less than 1. Clear? Because you know cos 0 equals to 1, maximum value 1. Okay, and cos pi by 2 equals to 0. So maximum value is 1 and minimum value is 0, and all other values are between 0 and 1. So obviously in this interval 0 to pi by 2, the cos value will be 0 to 1. Clear na? Okay, so now we have to get this result, x minus x cube by 6, this expression. So obviously let's multiply. Let's take the less than sign symbol. So this imply cos theta x, this is less than 1. This imply, let's multiply x cube by 6. So x cube by 6 cos theta x, this is less than x cube by 6. Now minus sign, so this imply minus x cube by 6 cos of theta x, this is greater than x cube by 6 minus x cube by 6. Okay, now this imply x minus, so x minus x cube by 6 cos of theta x, this is greater than x minus x cube by 6. Clear? Now x minus x cube by 6 cos theta x, this is greater than x minus x cube by 6. And what is x minus x cube by 6 cos theta x? This is sin x na, from equation number 2. So obviously we can say this imply sin x greater than x minus x cube by 6 from 2. Okay, and this was our proof that you have to prove sin x greater than x minus x cube by 6. So hence proved. Clear? Hence proved. Now let's solve another problem. Next question. Let's solve a problem, very important problem. Okay, and let's solve using Lagrange MVT. Okay, so next problem is from Lagrange MVT. Prove that sine 46 degree, this is nearly equals to 1 by root 2 1 plus pi by 180. Okay, you have to prove this. Sine 46 degree is nearly equals to 1 by root 2 1 plus pi by 180. Okay, solution. So let's take the function f of x equals to sin x. Okay, so by Lagrange MVT, obviously we know that f of a plus h, this is equals to f of a plus h f dash a plus theta h, yes or no, and 0 less than theta less than 1. Okay, so from here what you can say? Okay, let's write this. Now if I put let a is equals to 45 degree and h is equals to 1 degree. Actually a is equals to 45 degree, h is equals to 1 degree. So obviously you will get f of a plus h, that means sine 46 degree, yes or no? Okay, so what you are getting, f of 45 plus 1, that means 46 degree. This is equals to f of a, that means f of 45 degree. Okay, this is plus h means 1 degree into f dash a plus theta h. A plus theta h means a means 45 degree plus theta into 1 degree. Clear? Okay, this implies sine 40 f 46 degree means sine 46 degree. This is equals to f 45 degree, that means sine 45 degree plus 1 degree into f dash this. Acha, sin x fx equals to sin x, so f dash will be cos x. So this will be cos of 45 degree plus theta into 1 degree. Clear? Or you can say theta degree. Okay, now this imply this is sine 46 degree, this is equals to, this is sine 45 degree, okay, plus 1 degree into cos 45 plus theta, and theta is very small number na, theta is 0 less than theta less than 1, and you know that cos let's say any number cos x plus theta, when theta is very small, this is nearly equals to cos x. Okay, cos x plus theta, when theta is very small, that will be nearly equals to cos x. So obviously we can say that this will be cos 45 degree, but cos x plus theta is nearly equals to cos x. So obviously we have to change this equality sign to nearly equals to this. Okay, now this imply sine 46 degree. This is nearly equals to, what is the value of sine 45 degree? 1 by root 2. Okay, plus now 1 degree. Acha, we know that 180 degree, this is equals to pi radian na, pi radian. So what will be 1 degree? Pi by 180 radian. Yes or no? So in place of 1 degree we can write pi by 180. Okay, and what is the value of cos 45? Again 1 by root 2. So this implies sine 46 degree, this is nearly equals to 1 by root 2 is common, so this will be 1 plus pi by 180. Okay, so hence proved. Clear? Now solve your textbook problems and question bank. Thank you so much.